Today we're going to be covering exponent rules.
Remember, with great power comes great responsibility.
The first exponent rule that we're going to cover is the one that most people seem to miss. So if I have some number, any number at all, and I raise it to 0, what do you think that would be? A lot of people might say 0. But that would be incorrect. The answer is actually 1. It doesn't matter what number it is, any number. It could be 5 raised to 0, it will equal 1. It could be 1,000 raised to 0, equal 1. It could be 5x squared, y cubed, z to the 10th power. If I raise that to 0, it's going to equal 1. The next rule we're going to look at is multiplying. So exponents actually tell us how many times to multiply by. If I have 2 and I multiply that by 2, I've done 2 steps of multiplication. So that's 2 squared, and that's going to give me 4. If I do another step of multiplication, that's 2 cubed, that's going to give me 8. So this number here is counting the number of times that something is being multiplied. So if I looked at this as a variable, let's say x, if I see x squared, that just means x times x. I'm counting how many times I'm multiplying. If I see x to the 4th power, that just means x times x times x times x. What about if I said x cubed and then I multiplied that by x squared? So remember, this number is just counting multiplication. And then all I'm doing is doing some more multiplication. So if this is x times x times x times x times x, how many times am I multiplying x? 5 times. So this is just x to the 5th power. So there's a pattern happening here. When you're multiplying numbers that have the same base, you're actually just going to end up adding the exponents together. 3 plus 2 gives me 5. Let's say if I had x to the 6th power, and I'm multiplying that by y to the 3rd power. Okay, so here I don't have the same base anymore. Now I have 6 x's being multiplied and multiplying that by 3 y's. But still, I only have 6 x's and 3 y's. So it's still just x to the 6th, y cubed. And we can write them next to each other like this to show that they're multiplying. But this is as far as this one can go because the bases don't match. But every time they do, you're able to just add the numbers because you're just counting how many multiplications you're doing. So if this is 7 multiplications of x, and this is 10 multiplications of x, x to the 7th times x to the 10th is the same thing as x to the 7 plus 10 x to the 17th power. That was multiplication. Let's get into division. Let's say I've got an example where I have some number, let's make it a variable w, and I'm raising that to the 5th power. And then I have another number w, and I'm raising it to the 3rd power. So this is w to the 5th divided by w cubed. So I'm looking at the exponent telling me how many times to multiply. So it's w times w 5 times. And then this one is w times w 3 times. So I've got 5 w's divided by 3 w's. And what we're looking at here deals with the fraction rule, where anything divided by itself is going to give you a 1. It could be any number. We have 2 divided by 2, that's going to equal 1. I can have 50 divided by 50, and that's going to equal 1. And I can also have w divided by w to give me a 1. So each time I have a w that matches the top and the bottom, I can turn those into a 1. So that can become a 1, that can become a 1, and that can become a 1. So that all that's left is these 2 w's on top. So they're going to stay on top. When this cancels all of these out, this is still just a whole bunch of 1s. 1 times 1 times 1 gives me 1. So it's w times w, so w squared over 1. Anything over 1 is just itself. It's a whole number. So our final answer is going to be w squared. Okay, but maybe you don't want to go through doing all of this work. There is a trick here that's happening. So I had w to the 5th power, and I'm dividing it by w to the 3rd power, and that's going to give me w squared. So notice what's happening here is actually subtraction. I had 5 w's being multiplied, and I divided 3 of them away. So this is equivalent to 5 minus 3, and that's how I get w squared. Okay, but what happens if the denominator is bigger than the numerator? Let's go back to still the w's. So w cubed is now on top, and w to the 5th power is now on the bottom. So when you're dealing with this situation, you're still doing subtraction. You're still going to have the 3 w's and 5 w's, and you're still looking for 1s. So there's a 1, there's a 1, there's a 1. So everything on top became 1s. 1 times 1 times 1 is just 1, and then you have 2 w's left, so w squared. So this is the longhand version. If you'd like to use this way, that's fine, but let's look at what's happening mathematically so that you don't have to write everything out every single time. So what I like to do here is I like to think about which number of these exponents is bigger. Before, the 5 was on top, so that's where we put the w squared, was on top. But this time the 5 is on the bottom. So this right here, when we divide, it's going to become a 1. And now this w cubed is going to go down to the w to the 5th power. So we're going to do this subtraction underneath the fraction bar now instead of above it where it was before. So this is now 5 minus 3, but it's in the denominator. So we still get the same answer with 1 over w squared.
How can we raise a power to another power? Or we could ask, how can we raise one exponent to another exponent? So with those questions in mind, we're ready to start our conceptual journey. Now let's pretend that this orange circle represents some value, whatever you want it to be. Now if I raised it to the 5th power, I could expand it as 5 orange circles being multiplied together. That would mean the same thing. Now what if instead of an orange circle, I had something like 4 squared being raised to the 5th power? Well, the same relationships associated with the exponents would apply, and I would treat that 4 squared the same way that I treated that orange circle, and I would replace each one with 4 squared. So now instead of 5 orange circles being multiplied together, I have 5 4 squareds being multiplied together. Now to push this a little bit further, I know that 4 squared can be rewritten as 4 times 4. And I can rewrite the rest of the 4 squareds in the same way. So I replace each 4 squared with 4 times 4. And now I have one long expression with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 4s being multiplied together. So this is equal to 4 to the 10th power. Cool. The question now is, how do we use the exponents of 2 and 5 and end with a result of 10 in the simplified answer? Hopefully you saw that multiplying 2 times 5 does result in 10. And this relationship actually is going to be another law of exponents that applies whenever you raise one power to another power. So this law states that whenever raising an exponent to another exponent, in this case x to the a raised to the power of b, it's going to equal x to the a times b, the product of the two exponents. So if, for example, we replace those variables a and b with actual numbers, in this case x to the 7th raised to the 3rd power, using this law of exponents, we would have 7 times 3 as our new exponent, which would equal x to the 21st power, which is our simplified form answer. So in addition to understanding the concept, the main part of the procedure to remember here is that when you raise an exponent to another exponent, you multiply them.
Next is negative exponents. So exponents are actually not supposed to be negative. And if you see one, that should be your first indication that there is some exponent rules that you need to work through. So let's say I've got some number, we'll make this variable x. And I have a negative exponent here of negative 3. X is being raised to negative 3 in this case. So when an exponent is negative, what we usually like to think about is that this is telling me that it's on the wrong floor. So every whole number is still just a fraction, so it's over 1. Right now, this x, because it is in the whole number spot, it means that the negative is telling me that it shouldn't be on top anymore. It should actually be on the bottom. So what I'm going to do is actually move it down. And when I move it down, the top is going to become a 1. And then this is now a positive x cubed. I've moved the variable down so that it will turn positive. Let's look at what happens if it's already on the bottom. So if I'm looking at some letter or some variable, and now it's in the denominator and it's negative. Well, that still means it's on the wrong floor. It needs to get on the elevator and go up this time. So now I'm going to have the x move up so that the 3 can become positive. And then that's how we get the answer of x cubed. Anything over 1 is just a whole number. All right, so let's combine a couple things into one so that we can see what's going on. Let's say I have 3x to the negative 2, and it's over y. 3x to the negative 2 over y. So in this case, this exponent is only touching the x. That 3 is not involved with this exponent at all. So this negative 2 is only going to move the x. So that now this 3 stays on top, and the x squared goes to the bottom to become a positive exponent. So that this is going to give us 3 over yx squared. What about if I had parentheses, though, around the 3 and the x? Well, now these parentheses are making it to where this negative 2 is affecting both of them. So when you are trying to change this to a positive exponent, you have to move the entire thing, everything in parentheses. So nothing gets left up here. This whole thing is going to move down. So we'll just have a 1 up there. And then this y is here. And then the 3x, I'm going to leave it in parentheses. And now this exponent becomes positive. But this isn't done yet. We have this squared here. What we need to do is we need to distribute it so that it can be fully simplified. So we still have the 1. The y is not inside those parentheses, so it's still just there. But this squared needs to go to the 3 and to the x because of the parentheses that are there. So 3 squared is actually going to give me 9, and then x squared. So now my final answer is 1 over y 9x squared.
Rules of exponents, so you now done this. Raise it up to a 0, that's 102. Negative exponents, you can switch it up. Yeah, straight A's, now clap it up. You subtract, 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 you subtract. You can add, 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 you can add. Exponent, 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 exponent. My grade go hard, concrete. Just ace this test, no cheat. I don't cheat. Grades looking so sweet. Rapping exponents on this dope beat. I'm on track, graduation pace. Part of rule, only words with the same base. When you multiply, add on powers. My grades higher than a wheelless tower. X2 times X, that's X to the 4. But wait a second, that's more. When there's coefficients, don't you add them up. Just multiply, and that's enough. Rules of exponents, so you now done this. Raise it up to a 0, that's 102. Negative exponents, you can switch it up. Yeah, straight A's, now clap it up. You subtract, 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 you subtract. You can add, 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 you can add. Exponent, 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 exponent. rules, listen to the next rule. Portion rules divide. Students, don't you get fooled? Powers were the same, they subtract the exponent. There's more to this problem, just give me a moment. Fractions in the front, all you gotta do is simplify. Pretty soon your grades will get pretty high. Now you know the quotient rule. Rules, you know we're the best. Rules of exponents for you mad dummies. Raise it up to a zero, that's 102. Negative exponents, you can switch it up. Switch it up, straight A's. Now clap it up. You subtract. 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 You can add. 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 You can add exponents. 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 You know I'm the best student, so I go last. I think fast, I get math, I run this class.
Always on top, call me numerator. Arithmetic in my head, no calculator. Power of a power, that's on me. Works like the distributive property. Just pay attention to the number on the outside. That's the number we need to multiply.
To all the exponents in parentheses, all the females yelling, I say, girls, are you looking for the answer? I'm the boss, I'm the man, mathematic master. Exponents, in parentheses, all the females yelling, go out and help me please. Looking for the answer, I'm the boss, I'm the man, mathematic master.
Okay, so that covers the exponent rules. Hope you got some notes, and make sure to do the practice activities that go with this topic. And I look forward to seeing you in the next one. Bye!